Hello, my name is Joshua Moore. I'm a graduate research assistant at Mississippi State University. Today I want to give you a brief demonstration of running the Powders Nexran Xapp on the OAIC platform. So Nexran Xapp essentially implements RAN slicing by creating slices and then binding those slices to the node B. Those slices are then bound to UE, which implements the downlink RAN slicing. So this is the instructions that we create for the OAC platform. You can find this through our website or through our GitHub, and these are built using Sphinx. And as you can see down here, once you follow all this and get all of the other components and services installed, then you can choose which Xapp you want to deploy and run. Today we're going to run the Nexran Xapp. So we're going to start by installing the SRS RAN with E2 specifically for the Nexran. So I'll go ahead and get started. So first of all, we want to start in the OAIC directory, and we're going to clone down a different SRS LTE. So I'll copy this command. And we'll CD directly into that, making sure we're in the right directory. And if a build folder exists, go ahead and remove that. We'll go ahead and create one since it doesn't already exist. We'll export this path real quick. And depending on your machine's performance, it may take longer than the demonstration here today or shorter time period to compile this SRS RAN. But we want to make sure that we select this whole CMake command and copy it, like so. And paste it directly in the terminal. And it's telling me to install CMake, so I'll go ahead and follow that direction. We'll go ahead and run that CMake command again now. So it's telling me that the package does not exist. So let me go to our instructions and fix that real quick. It's most likely a dependency issue. Because we want to see a complete status there. Okay, and that's what we want to see there. Perfect. So we'll continue with this instruction set here. So now we're gonna make that. Okay. It's important to realize that we do want to see this 100% here. If there are errors, then we need to go back to the instructions and be checking over to make sure we've done everything properly. So it should install correctly there. Also, these two commands here, we can go ahead and copy them both. These are both very important. They're going to install our configuration files for SRS RAN. So we're going to copy these in here. And I'll say yes to the prompt there. Okay. So we're going to go ahead and clone down the Nexran source code so we can go ahead and build that Docker container which will run. We can cd there, which is the next command, and we're going to build it and tag it with our repository that we want to use in the port, like so. And we'll replace the machine IP address with the one we copied, which in my case is 192.168.0.135. Go ahead and save that and move to the next instruction. So now we can go ahead and add UE1 because we're doing ZMQ. I'll go ahead and start a tmux session. So I'll quickly install that. And tmux allows me to have different windows in this single terminal, which is pretty handy because we'll have several terminals that we'll have to juggle. So we'll go ahead and start the EPC in this terminal. And we need to export some environmental variables so we can start the eNodeB in the second terminal window. So I'll do that like so. And then the srs eNodeB command, we'll go ahead and copy and paste that there. And there will be a lot of output from the eNodeB, but we're specifically looking for the RIC state to stay established down there at the bottom, which it did. So we can move on to the UE. So we'll go ahead and start this here, as so. And we'll wait for a successful connection between those two. It will become clear very soon why I have 3 terminal windows open. Okay, so that connected successfully. I'm going to open a new pane and start the iPerf server. The iPerf server is going to allow us to exchange traffic so we can monitor the throughput. So I'll go ahead and install iPerf real quick and then run that command. So that's perfect, that server started there. So in this top left window, I'm going to go ahead and connect to that server so we can watch the downlink traffic that's generated. I do need to go ahead and SSH to my machine here, so 1 second. I'll go ahead and do the same here so we'll be prepared. Okay, and like I said, we'll paste that command in there and we should start seeing the exchange of traffic. So in the middle we have transfer in megabytes per second, and then we have bandwidth on the right side. We're going to go ahead and deploy that Xapp. So it is running in the near real-time RIC. So in our rightmost terminal here, we'll export these environmental variables. Okay. We'll go ahead and run this top command, which, as you can see, uses that Nexran onboard.url to onboard successfully this Nexran Xapp. Okay. There's a small error in the onboard.url that we'll correct, so that shouldn't have been a problem on your screen, just mine. So we can see that the Nexran Xapp is now successfully onboarded. I'll quickly get my pods and make sure that it is indeed in the running state, and all these other pods as well should be in the running state. If you need to restart for any reason the Nexran, the EPC eNodeB Nexran, you can do so with this command. for now. In my bottom left terminal, I'll get the logs up and running, which I like to have. So I'll paste that there at the bottom left terminal. We'll go ahead and make sure we can communicate with the Nexran Xapp using this export command. Okay, that's perfect. We got our IP address, and what we're going to do now is we're going to go and run the script that's going to create a fast and slow slice, and I'll go ahead and show you that script briefly. So we'll go in here, and simply put, the script is going to run these bash commands here. It's going to communicate through the northbound interface. We're going to list the node B, the slices, the UEs. Then we're going to create the node Bs and the slices. We're going to bind those slices to the node Bs and then to the UEs, which is going to change the resources. Okay. And as we run this script, we'll see a change in the throughput. So if you'll direct your attention to the top left terminal as I run this script. And we'll also see some output from the logs of the Nexran as well, exchanging those messages. So we definitely do see a drop. It's a slight drop in the throughput here that you can observe. And we'll go ahead and drop that even more drastically by inverting the slices here. Simply paste this in your terminal here. And we should see this throughput drop pretty drastically as we do here. Going from about 30 megabyte per second to about 8. So again, thank you for your time. This has been a brief demonstration. I hope this has helped some. If you have any questions, please reach out to us. Thank you.